Welcome to today's presentation, an introduction to 3D printed liquid-cooled heatsinks for power electronic applications. My name is Christopher Rognano, and I am acting as VP of Business Development for IQ Evolution, but I'm also the founder of Foxy Power GmbH, a company dedicated to help startups and manufacturers of disruptive technologies to bring their product into the market. IQ Evolution has been founded in 2006 in Aachen, Germany. It started with manufacturing nickel-based coolers for high-power laser diodes. Nickel has a very high thermal conductivity, but it's difficult to export. By using an artificial intelligence, IQ was able to improve the internal flow and turbulences, which increased the heat flux density significantly. Now they were able to use stainless steel as a material which is corrosion-free, cost-effective, widely available, and has no export restrictions. With that, I'm going to show you in the next slide a video of the production process. What you can see here is the Trump laser machine, which is off the shelf from the outside, but quite customized internally. Here you can see the equipment to bring the powder and generate the cooler. The only information the customer has to provide is a CAD file with the shape of the cooler. The stainless steel powder is being filled up, and then the form is being heated up to preheat the powder. Now the powder is distributed. The laser is turned on, and wherever the laser hits, the particles melt and the first layer of the cooler is created. The process is repeated, and so layer for layer is built. We can build any form and shape. Now you can see the live process. By the way, even though many people think that additive manufacturing is for samples only, IQ has planned with automotive mass production quantity from the beginning. And here you see layer after layer, the complete cooler is being constructed. On purpose, this sample was kept open, so one can see the internal structure. One often asked question is, why do you not use aluminum or copper as a material, as the thermal conductivity is much higher than stainless steel? And the answer to it is, because of the very small wall thicknesses, the cooler works with turbulences and not thermal conductivity. Aluminum and copper would have higher wall thicknesses, and therefore the thermal performance would be worse. What you see here is our standard cooler for TO247, the twin, 4 and double 4. More coolers are being made, for example the 3, 6 and double 6, and any other number can be made. The cooling performance is incredible. With the IQ Twin and a 50-50% water-glycol mix, a third party measured 360 watts total, or 180 watts per square centimeter. With pure water, that performance would be roughly 50% higher. On the 4 and double 4, we can get 670 watts and 1.35 kilowatt respectively. And again, any shape and form is possible with additive manufacturing. Now I'm going to show you the flow rate versus pressure drop of an IQ Twin. In the beginning, we started with the IQ Twin regular, which requires a high pressure drop and a low flow rate. However, in the automotive world, there is a requirement from the combustion engine world which demands a high flow rate and a low pressure drop. This specification has been taken over into the EV world. During our collaboration with various OEMs and Tier 1 suppliers, we evaluated the IQ Twin full flow, which will also be automotive qualified. Now the customer can even start with a 100 millibar pressure drop and get roughly 1 liter per minute at 200 millibars. Hence, we do have two versions of the twin. Here you can see the temperature versus pressure drop. The initial water temperature is 21 degrees C. The positive surprise was that the full flow version only has a 51 degrees C temperature at 100 millibar, and that in general it is 7 to 8 degrees C better compared to the regular twin. Since IQ Evolution is located in Aachen, they work very close with the IZEA Institute of WTH Aachen. Professor Rick Donker is heading it and is well known in the power electronics world. In this slide, you can see a bidirectional DC-DC converter with roughly 20 kilowatts. The DC-DC was run at 450 kilohertz switching frequency with silicon carbide MOSFETs from Cree speed and featured roughly 100 kilowatts per liter. The double four cooler was used to cool semiconductors from one side and coils from the other side. That's another great advantage of this technology. You can get cooling from both sides, and you can cool semiconductors as well as passive. With courtesy of TU Eindhoven, you can see here a combined cooling for discrete FETs and an inductor. In this case, GaN device has been used. What you can see is the inductor. On top of it is the DBC, which is attached to the cooler. The GaN devices are in between the PCB and the cooler to guarantee the most effective cooling. The PCB has been contacted through those pins you can see here, and which are surrounded by insulation material to ensure electrical isolation. This idea could also be transferred into a power module. We can not only cool discretes, also modules can be cooled with our standard coolers. In this example, a converter with 210 kilowatt has been designed. The overall losses was about 4.2 kilowatt, which means 350 watt per module. The challenge was a tight volume and size restriction, and thus the customer couldn't go with the standard cold plate. With the IQ Evolution cooler, they were able to cut the number of modules by half and additionally size them down significantly. For that reason, the weight has been significantly reduced from almost 10 kilogram to 1/2 kilogram, which is a 96% reduction. Each side of the cooler can dissipate 700 watts, and that is at a flow rate of roughly 1200 milliliter per minute and 0.8 bar. With those kind of savings, the cost of the cooler doesn't play a role, because the system cost reduction is significant. We're already coming to an end of the presentation, so this slide is just to show you some reference customers which are leading the industry, from Bosch to Trump. Again, IQ Evolution is successful in the market for 15 years and recently started its journey into cooling semiconductors in passives. So with this slide, I want to summarize IQ Evolution in a nutshell. Key applications are welding, induction heating, and energy storage, as well as off-board chargers. In welding, the EU Eco Directive forces efficiency to be above 85% from 2023 onwards. Induction heating, energy storage, and off-board charger already use liquid cooling for their system, the batteries or the cables, and thus it is easy to move to IQ Evolution and save weight, size, and system cost. In automotive, the coolers can be used in powertrain to reduce the number of silicon carbide FETs, but also in onboard chargers, DC-DC, or in autonomous driving application to cool the NVIDIA chip, for example. IQ is cooperating with the global top 5 tier 1 and received the first PO. Further discussions with OEM and tier 1 automotive suppliers, as well as semiconductor manufacturers, are being done as we speak. And the idea is to create a module where the IQ cooler is an integrative part of the total module to optimize the thermal resistance and heat dissipation. In aviation, we are talking with several industrial leaders for powertrain and communication applications, as the electrification of aircraft has created additional industries like drones and VTOL. Further, we are in discussion with inductor manufacturers to find a solution for high-end servers which have issues with heat right now. And also, we think that liquid cooling will be used in telecom business as the power density is growing with 5G here as well. Features of the coolers are thin and ultra low weight, a heat flux density of 200 watts per square centimeter, and a cooling performance from both sides. As mentioned before, additive manufacturing is for rapid prototyping as well as for automotive quantities. The possible use cases are either discrete, or you could integrate the cooler into the PCB. You can cool passive, or you can use the technology to downsize the size of the module and thus weight and system cost. Other applications could be also replacing the bus bars or cooling in between 3 cells of a lithium-ion battery. A lot is possible with that technology, and this slide should just give you some ideas. If you have any questions, ideas, or require samples, please feel free to contact me.